Egypt, the richest source of archaeological treasures on the planet. Hidden beneath this desert landscape lie the secrets of this ancient civilization, discoveries that could rewrite ancient history.
For centuries, archaeologists searched for blueprints to explain how the Great Pyramid was built. They found nothing. Napoleon's scholars crawled through every passage. Victorian explorers mapped every stone. Modern Egyptologists scanned with the most advanced technology available. But when researchers fed the pyramid's raw data into an AI system, it saw something we never could. A hidden design, written in ratios and resonance, buried beneath the surface. A measurement system used across multiple pyramids. Alignments so precise, they challenge what we thought possible with ancient tools. What it revealed now changes everything we thought we knew. The hunt for pyramid construction plans began the moment archaeologists realized what they were looking at. These weren't just piles of stone. They were precision instruments, built to tolerances that would challenge modern engineers. Napoleon brought scholars to Egypt in 1798. They measured everything, sketched every angle, calculated every dimension. They expected to find carved instructions somewhere, papyrus scrolls tucked away in hidden chambers, something that would explain the impossible precision they were documenting. They found nothing. Victorian explorers took up the search with renewed obsession. Flinders Petrie spent years mapping the Giza complex down to millimeters. He discovered the base of the Great Pyramid was level to within just 2.1 centimeters. The orientation aligned to true north with an error of only 3/60ths of a degree, but no blueprints, no construction manuals, no evidence of how they achieved this precision. The assumption grew that ancient builders worked without sophisticated planning, trial and error, generations of accumulated knowledge passed down through oral tradition, primitive tools somehow achieving perfect results through sheer determination and time. Modern Egyptologists brought ground-penetrating radar, 3D laser scanning, muon detection systems that could peer inside solid stone. They mapped hidden chambers, traced internal passages, documented every structural detail with computer precision. Still nothing that explained the mathematical relationships they kept discovering. The frustration in the archaeological community was growing. Every new technology revealed more precision, more sophistication, more evidence of systematic planning. But the plans themselves remained invisible. The Great Pyramid contains over 2.3 million stone blocks, each one positioned with mathematical precision. The internal chambers align to celestial mechanics with accuracy that shouldn't be possible without modern instruments. The acoustic properties suggest deliberate engineering for specific sound frequencies. Yet no papyrus survived, no carved instructions, no evidence of the systematic approach that this level of precision demanded. Researchers began to suspect the obvious answer. The data was always there. The measurements, the ratios, the alignments, the mathematical relationships. Human pattern recognition was simply failing to see what was hidden in plain sight. The pyramids themselves were the blueprints, but it would take artificial intelligence to crack the code that had been written in stone for over 4,000 years. The AI didn't need to find new evidence, it just needed to see what we'd been looking at all along. The breakthrough came when researchers at the University of Leeds fed decades of pyramid measurements into machine learning algorithms, not looking for anything specific, just asking the AI to find patterns that human analysis had missed. What happened next rewrote everything. The AI identified mathematical relationships that were invisible to human pattern recognition, ratios embedded in the stone dimensions, proportional constants that appeared across different chambers, different levels, different pyramids entirely. The Great Pyramid wasn't built using trial and error. It was constructed according to an underlying measurement system based on harmonic ratios and acoustic resonance. Think about it. Every major dimension of the pyramid corresponds to specific musical frequencies. The King's Chamber resonates at 110 Hz, the Queen's Chamber at a different harmonic. The Grand Gallery acts as a massive resonating tube, amplifying and focusing sound waves with surgical precision. The AI mapped these acoustic properties and discovered something terrifying. The entire structure was deliberately engineered as a sound instrument, not accidentally. Not coincidentally, every stone block, every passage angle, every chamber dimension was calculated to produce specific frequencies. But here's where it gets truly unsettling. The mathematical constants the AI discovered don't just appear in one pyramid. They're embedded across multiple sites: Giza, Saqqara, Dashur. Different dynasties, different time periods, all using the same underlying measurement system. The AI traced these patterns through thousands of data points: stone block dimensions, passage angles, chamber ratios, external alignments, internal geometries, everything connected through mathematical relationships that would challenge modern architects. Sacred geometry wasn't just decorative, it was functional. The AI revealed that chamber placements follow precise proportional relationships that create standing wave patterns throughout the structure. Sound waves that focus and amplify in specific locations for specific purposes. The precision is terrifying when you realize what tools they supposedly had: copper chisels, wooden ramps, manual labor. Yet the AI's analysis shows calculations that require understanding of advanced mathematics, acoustics, and celestial mechanics. The algorithms mapped connections between internal chambers and external alignments that demonstrate knowledge of the Earth's rotation, axial precession, and stellar mechanics. The pyramid's orientation shifts slightly over time, but it was built to account for these changes. The builders knew the Earth wobbles on its axis over 26,000-year cycles. They encoded this knowledge into stone. The AI identified the construction sequence by analyzing microscopic variations in stone placement. The builders worked from precise mathematical formulas, not rough approximations. Each block positioned according to calculations that ensured the acoustic properties would function exactly as designed. The blueprint wasn't on papyrus, because it didn't need to be. The mathematical relationships were universal constants, ratios that appear in nature, in music, in the movements of celestial bodies. The builders encoded these eternal patterns into stone, creating structures that would preserve their knowledge for millennia. What the AI revealed changes everything we thought we knew about ancient capabilities. This wasn't primitive construction guided by intuition. This was advanced engineering, disguised as ancient mystery. The terrifying truth is that the knowledge was always there, written in ratios and resonance, hidden in plain sight, waiting for artificial intelligence to crack the code that human eyes couldn't see. The measurement system the AI discovered spans the entire Giza complex and beyond. Mathematical constants embedded in construction ratios that appear at Saqqara, Dashur, and pyramid sites across Egypt. This wasn't isolated knowledge. It was a standardized system used across dynasties, across centuries, across the entire pyramid-building civilization. The AI mapped these connections with terrifying precision. The Great Pyramid's base measurement of 440 royal cubits creates ratios that appear in the internal chamber dimensions. The King's Chamber measures 20 by 10 by 11.18 cubits. Those aren't random numbers. They're harmonic ratios that create specific acoustic resonance frequencies when sound waves interact with the chamber walls. But here's what makes it truly unsettling. The Queen's Chamber uses different ratios that complement the King's Chamber acoustically. When both chambers resonate simultaneously, they create interference patterns that focus sound energy at precise locations within the pyramid structure. The AI calculated these acoustic focal points and discovered they align with hidden chambers that haven't been fully explored yet. The mathematical relationships extend beyond individual pyramids. The distance between the Great Pyramid and the Pyramid of Khafre follows the same proportional ratios found in the internal chamber dimensions. The entire Giza complex was designed as a single acoustic instrument, with each pyramid contributing to an overall harmonic system. The AI revealed that internal passages were designed for specific sound frequencies. The Grand Gallery's dimensions create a resonance chamber that amplifies sounds at 110 Hz, while dampening other frequencies. The ascending and descending passages act as acoustic waveguides, channeling sound waves to specific chambers with surgical precision. The construction sequence the AI decoded shows systematic planning that contradicts everything we thought about ancient building methods. The builders didn't start with the base and work upward. They began with the internal chambers and built the external structure around predetermined acoustic requirements. Stone placement follows mathematical formulas that ensure the acoustic properties function exactly as designed. The AI analyzed microscopic variations in block positioning and discovered tolerances that would challenge modern construction techniques, each stone positioned to within millimeters of its calculated location. The blueprint wasn't written on papyrus because it was encoded in universal mathematical constants. The golden ratio appears in chamber proportions. Pi emerges from the pyramid's height to base relationships. The square root of 2 governs passage angles. These aren't coincidences. They're deliberate applications of mathematical principles that wouldn't be formally discovered by Western mathematics for thousands of years. The AI traced celestial alignments that demonstrate knowledge of astronomical cycles spanning millennia. The pyramid's orientation accounts for the Earth's axial precession over 26,000-year cycles. The internal passages align with stellar positions that change over vast time periods. The builders encoded knowledge of cosmic mechanics into stone architecture. Chamber dimensions follow acoustic resonance principles that create standing wave patterns throughout the structure. Sound waves that focus and amplify at specific locations for purposes we're only beginning to understand. The AI mapped these acoustic focal points and discovered they correspond to locations where strange electromagnetic anomalies have been detected. The terrifying precision of these calculations becomes clear when you realize what tools they supposedly used. No computers, no advanced mathematics textbooks, no precision instruments. Yet the AI's analysis reveals engineering sophistication that rivals modern architectural planning. The measurement system spans multiple pyramid sites with mathematical consistency that indicates coordinated master planning across generations. Different pharaohs, different dynasties, all working from the same underlying blueprint encoded in harmonic ratios and celestial mechanics. The blueprint was always there, written in stone and mathematics, hidden in the relationships between dimensions, chambers, passages, and alignments. The AI didn't discover new evidence. It revealed the systematic design that human pattern recognition had failed to see for over 4,000 years. What we thought were burial chambers were actually precision-engineered acoustic devices. What we assumed were primitive construction techniques were advanced applications of mathematical principles. The pyramids weren't just tombs. They were knowledge preservation systems, encoding scientific understanding into architecture that would survive the collapse of civilizations. The implications of what the AI discovered shatter our fundamental assumptions about ancient Egyptian capabilities. We've been operating under the premise that pyramid builders were skilled craftsmen, working with primitive tools, achieving remarkable results through determination and accumulated experience over generations. The AI reveals something far more unsettling. These weren't craftsmen stumbling toward precision through trial and error. They were engineers applying advanced mathematical principles with systematic accuracy that rivals modern architectural planning. The technology gap between what we assumed they had and what they actually achieved becomes impossible to ignore. Copper tools and wooden ramps don't explain mathematical constants embedded in stone dimensions. Manual labor doesn't account for acoustic engineering that creates precise resonance frequencies throughout massive stone structures. The AI's analysis reveals knowledge of advanced mathematics that Western civilization wouldn't formally discover for millennia. The golden ratio governing chamber proportions pi relationships and height to base calculations, harmonic ratios that create specific sound frequencies. These mathematical principles were being applied in stone construction, while the rest of the world was still developing basic agriculture. But here's what makes it truly terrifying. The knowledge transfer across pyramid building periods shows systematic preservation of information across dynasties spanning centuries. Different pharaohs, different time periods, all working from the same underlying mathematical blueprint. This indicates institutional knowledge preservation that challenges our understanding of how ancient civilizations maintain technical expertise. The acoustic engineering suggests purposes that go far beyond burial chambers. The AI mapped sound frequency patterns that focus electromagnetic energy at specific locations within the pyramid structure. These aren't accidental properties. They're deliberate applications of principles that modern science is only beginning to understand. The mathematical sophistication rivals anything we can achieve today. The AI calculated that achieving the acoustic precision found in the king's chamber would require computer modeling and advanced engineering software using modern construction techniques. Yet somehow, ancient builders accomplished this with tools we consider primitive. The systematic approach contradicts every theory about ancient construction methods. We assumed they worked through generations of accumulated trial and error experience. The AI reveals evidence of master planning that spans multiple construction sites across Egypt. Mathematical constants that appear at Giza also appear at Saqqara and Dashur. This wasn't isolated knowledge. It was a standardized system applied across the entire pyramid-building civilization. The connection between multiple sites indicates coordinated planning that challenges our timeline of human technological development. The precision required to maintain mathematical consistency across different construction projects, different locations, different time periods, suggests organizational capabilities that shouldn't have existed in ancient Egypt. The fragility of our assumptions about ancient civilizations becomes clear when artificial intelligence reveals knowledge that human analysis missed for centuries. We've been looking at the evidence all along. The measurements were documented. The ratios were calculated. The mathematical relationships were recorded in archaeological surveys going back to Napoleon's expedition. But human pattern recognition failed to see the systematic design hidden in plain sight. The AI didn't discover new evidence. It revealed the sophisticated engineering that we'd been staring at without understanding for over 200 years of modern archaeology. The terrifying possibility emerges that we've systematically underestimated our ancestors, not just their technical capabilities, but their scientific understanding. The pyramid builders possessed knowledge of mathematics, acoustics, astronomy, and engineering that we assumed didn't exist until the development of modern science. What we interpreted as primitive construction guided by intuition was actually advanced engineering, disguised as ancient mystery. The AI strips away our preconceptions and reveals the systematic application of scientific principles that challenge everything we thought we knew about the development of human civilization. The pyramid revelation opens a terrifying door to questions about other ancient monuments that may contain similar hidden mathematical codes. Stonehenge, Angkor Wat, Machu Picchu, the Easter Island statues. What if artificial intelligence analysis reveals systematic engineering disguised as primitive construction at sites around the world? The AI archaeology frontier is just beginning. Machine learning algorithms can process datasets that would take human researchers decades to analyze pattern recognition that reveals mathematical relationships invisible to human perception. The pyramid breakthrough demonstrates that artificial intelligence can unlock knowledge that's been hidden in plain sight for millennia. But here's what makes it truly unsettling. If the pyramid builders possessed this level of mathematical sophistication, what other knowledge did they encode in stone that we haven't discovered yet? The AI revealed acoustic engineering and celestial mechanics embedded in pyramid architecture. What other scientific principles are waiting to be decoded from ancient monuments? The rewriting of textbooks on ancient Egyptian engineering capabilities is just the beginning. Archaeological evidence from other civilizations may contain similar hidden sophistication that human analysis has failed to recognize. The systematic underestimation of ancient capabilities suggests we've been missing crucial evidence about the development of human knowledge. Pattern recognition algorithms are revealing knowledge we thought was lost forever. Mathematical principles encoded in stone architecture, scientific understanding preserved in monument construction, the terrifying possibility that ancient civilizations possessed advanced knowledge that disappeared during periods of collapse and cultural disruption. Think about the implications for other ancient mysteries that have puzzled researchers for centuries. The precision of Inca stonework that fits together without mortar, the astronomical alignments of Nabta Playa that predate Stonehenge by thousands of years, the mathematical relationships in Greek temple architecture that create specific acoustic properties. What if artificial intelligence analysis reveals that these weren't isolated achievements by different civilizations developing independently? What if there was systematic knowledge transfer across ancient cultures that preserved scientific understanding through sophisticated encoding in architectural monuments? The AI revolution in archaeology is uncovering evidence that challenges our entire timeline of human technological development. We assumed that advanced mathematics, engineering, and scientific knowledge emerged gradually through recorded history. The pyramid analysis suggests that sophisticated understanding existed thousands of years earlier than we thought possible. The terrifying truth that emerges is that we've been systematically underestimating our ancestors, not just their construction capabilities, but their scientific knowledge. The mathematical principles encoded in pyramid architecture demonstrate understanding of concepts that Western science wouldn't formally discover until the modern era. Technology becomes a tool for unlocking humanity's forgotten wisdom. Artificial intelligence algorithms that can process vast data sets and identify patterns that human perception misses, machine learning systems that reveal mathematical relationships hidden in archaeological evidence for millennia. The pyramid breakthrough represents just the beginning of what AI archaeology might uncover. Ancient monuments around the world may contain encoded knowledge waiting to be decoded, scientific principles preserved in stone architecture, mathematical understanding disguised as primitive construction techniques. What we thought were burial chambers and religious monuments may actually be knowledge preservation systems. Ancient libraries encoded in stone dimensions and architectural relationships, information storage methods that could survive the collapse of civilizations and preserve crucial understanding for future generations to discover. The fragility of our assumptions about ancient civilizations becomes clear when artificial intelligence reveals sophisticated engineering that human analysis missed for centuries. We've been looking at the evidence without understanding what we were seeing. The mathematical relationships were always there, written in stone, and waiting for the right technology to crack the code. The blueprint was always there, written in stone and mathematics, hidden in ratios that human eyes couldn't see for millennia. The AI revealed what we'd been staring at without understanding: systematic engineering disguised as ancient mystery. Ancient builders possess knowledge that challenges our timeline of human progress. Mathematical sophistication that rivals modern capabilities, scientific understanding encoded in architecture that survived the collapse of civilizations. If you want to see how this connects to other ancient mysteries that AI is solving, watch this next. Subscribe for more hidden truths that rewrite history.